Hello and good afternoon. Welcome to our webinar on Stay Ahead of the Curve, Discover Key Insights on Word Power. This is our second webinar, which is focusing on the renewable energy, and I'm honored to be your moderator for the today's event. Did you know that wind power is the fastest growing source of renewable energy in the world? According to International Energy Agency, wind power capacity is expected to increase by 50% in the next 5 years. Major growth is due to technological advancements, declining cost, and supportive policies. In addition, the offshore wind market is expected to grow significantly in the coming years to come. In 2020 alone, the global offshore wind capacity reached 31.9 gigawatts, and it is projected to reach over 200 gigawatts by the end of 2030. This presents a huge opportunity for the wind power industry to contribute to the global energy transition. Today, we have gathered a panel of experts who will share their knowledge and insights on various aspects of wind power, including technological advancements, policy framework, and environmental considerations. Our experts come from diverse backgrounds and bring a wealth of experience to the table. We'll also discuss about the latest development in the wind power market, including economic opportunities from offshore wind power supply chain developments in different countries. We can explore the potential environmental effects of wind energy development, including minimization and monitoring strategies. In addition, we'll also learn about how wind power can revolutionize energy landscape across the globe. So, without further ado, I would like to extend a warm welcome to all the participants and express my gratitude to our speakers for this contribution. So, without further ado, I would like to introduce my first speaker for the event. Joining from in-house research team is my colleague Achal Agrawal with career spanning almost a decade. Achal is currently working as research consultant in renewable energy. She's one of the sought after member of TechSci family and has rich experience in management consulting. Over here, she looks after the renewable and sustainability division in TechSci research. Over to you, Achal.
Thanks a lot, Himanshu, for such a warm welcome and a brief introduction on wind power. So, just to add something on that, what is wind power? Wind power is basically the power which is produced by wind. Wind is used to produce electricity by converting the kinetic energy of air and motion into electricity. Basically, wind energy transforms the power of an inexhaustible resource such as wind into electricity. It is basically the growing renewable energy currently into the India as well as the global. Utilizing wind requires the construction of wind farms either on land or sea, like onshore or offshore, with dozens of wind turbines. Wind turbines can provide energy for on site use as well as export for sale. Himanshu, can you move to the next slide? This is basically the global renewable energy outlook, which is inclusive of wind, solar, biopower, geothermal, and other kinds of renewable energy. If we see the figures, in 2011, 9.52 exajoules of renewable energy was generated, and this is reached around 40.89 exajoules till 2022. And if we see the figures, in 2011, Europe and CIS was the dominating region globally. But if we compare in 2017, Asia Pacific surpassed the Europe and CIS and became the dominating region in terms of renewable energy generation. Other figures, North America is doing well in terms of renewable energy generation. South America, Middle East, and Africa are still the growing markets in terms of renewable energy generation. Himanshu, move to the next slide. This slide talks about renewable energy consumption. If we see, consumption was around 12.14 exajoules in 2011, which reached around 44.98 exajoules in 2022. Asia Pacific was the third dominating region until 2011, and in 2017 it surpassed US, North America, and became the largest region. Until now, till 2022, it is still the largest region which consume renewable energy the most, which is 19.77 exajoules. So, wind energy or wind power is a segment of renewable energy. Currently, solar and wind are the major two energies which are the dominating among the renewable power energies. If we talk about wind generation, around 440.38 terawatt hours was generated in 2011, and this figure reached up to 2151.66 terawatt hours in 2022. And if we notice, in 2011, Europe and CIS, inclusive of CIS, 42 or 43% was generating through Europe. The wind was generated through Europe. And currently, Asia Pacific is the dominating region which generated huge wind energy. The 26% was generated by Europe, then 23 was generated by North America, South America was 7%, and Middle East and Africa is still way behind in generating renewable powers like Saudi Arabia or other countries because their focus is mainly on oil and gas. This slide talks about the consumption part. In 2011, around 4.37 exajoules of wind power was consumed across the globe, that is 4.37 exajoules. And till 2022, around 20.16 exajoules of wind power was consumed across the globe. Currently, Asia Pacific holds around half of the market of the consumption of wind energy, around 43 to 45% held by Asia Pacific in 2022, and around 26% is holding by Europe and CIS. Middle East and Africa is not consuming wind energy more, and they are focusing on the renewable energy. The government is emphasizing on renewable energy, but right now they are just growing market. This is the installed wind turbine capacity in gigawatts. Currently, till 2022, 906 gigawatts of wind turbine capacity was installed across the globe. And if we see the figures, around 50% of the wind turbine was installed through Asia Pacific. Major reason is China, of course. China is the leading market in terms of wind capacity installation. And other major markets in Europe, it's Germany. In Asia Pacific, it's China and India. North America, US is the major contributor. Basically, these 4 to 5 markets are holding around 70% of the installed wind turbine capacity, which we are going to see in next slide. So this slide shows the top 5 countries which are currently installing the wind turbine capacity at the most. If you see China, US, Germany, India, and Spain, these 5 are the leading markets, and in 2021, these markets are holding around 75 to 80%. Same case in 2022. Other markets are growing and coming in the installation of wind turbines. But if you see, China is holding around 35 to 40% of the wind turbine installation in 2021 as well as 2022. Currently, across the globe, these are the top 10 wind turbine manufacturers in the world. First one is Vestas. We have an honored speaker from Vestas too. Siemens Gamesa is the second one. Goldwind, GE, Ambition Group, then Mingyang, Nordex, Shanghai Electric, As you see, Vestas is having a capacity of 9.60 gigawatt, and these players are holding around 30 to 40% of the overall wind capacity installations. These are the basic drivers, which are the driving factors and pushing factors for the wind turbine installation across the globe. First one is obviously climate change and environmental concerns. Every government is concerned about reducing the greenhouse gas emissions as well as carbon dioxide emissions from their country. Second one is energy security and independence. Every country wants to diversify its country's energy mix and reduce its dependence on imported fossil fuels, that is oil and gas. Third one is economic viability. This is the cost competitiveness with conventional sources of energy. You can see that the prices of wind turbines as well as solar panels decreased a lot in comparison to 2010 and 11. Fourth one is job creation and local economies. This is basically from the manufacturing and construction perspective of wind turbines, wind nacelle. Then policy support and incentives. If your country is going renewable, then the government is providing subsidies, tax incentives, feed in tariffs, renewable energy targets. Next one is technological advancements. Basically, new technologies are coming along with wind turbine designs, increased efficiency, also better integration with energy storage system. Next one is public awareness and support. Nowadays, countries are more focused towards accepting the wind turbines, accepting the energy through renewables, solar, wind, rather than going through the different energy infrastructure. Then energy transition. Nations are transiting towards more sustainable energy systems like Paris Agreement, which aims to limit global warming and promote the use of renewable energy sources. Last one is innovation and energy markets like decentralized generation and peer-to-peer energy trading. These are creating obviously new opportunities for wind power. These are some reports, Texar reports, which are related to renewables, the country reports as well as global reports. Thank you, Himanshu.
Thank you,
Thank
Anshul,
you,
for
Anshul.
providing information related to the key drivers which are fueling the growth of the wind power market in general and about the market size. Especially the slide which was about the key players in the market shed important light on the key players that are operating. Moving on to the next speaker, Mr. Satish Kumar Shanmugam. He's a experience of over 2 decades in the product design, new product developments, and is currently working as the team leader as Vestas R&D, which is a pioneering global leader in sustainable energy solutions, designing, manufacturing, and servicing wind turbines to drive the transition towards a cleaner and greener future. Welcome to you, sir.
Hi everyone. This is Satish here, and I'm from Vistas. So I started my career from 2000, so it's almost 23 years completed. And right from 2000, I'm just involved into the electromechanical areas. So right from Alstom T&D, then Schneider Electric, Rockwell Automation, and presently right now I'm working in Vestas R&D in Chennai. So most of my projects will be there in Europe and then in US. So these are the two major areas that where I really interact with the people and work on. So here I just wanted to give a overview. I think the initial overview already been given by Anchal, that the importance of the renewable resource. So as we know, like the non-renewable resource, it will deplete over time and it causes pollution as well. Whereas the renewable resources will not have this issue, so it's free from pollution and it will not deplete as well. And the pioneers of the wind turbine for the electricity. So earlier it was windmill, so we used to convert the wind energy to the mechanical energy, and that was windmill. So the initial pioneers of the wind turbine for generating the electricity was the Danish people, and even the Vestas is, I can say Vestas is also the pioneer and the first steady supply of power. So that's the like a quick introduction on the renewable resource as well as the windmill, uh, the first windmill what we have, what where it was started. So can we have the next slide? Yeah, here are the components of the wind turbine. So these are all the things which uh, we have in wind turbine for generating the electricity. So the earlier it was like a lattice towers were there to have the blades mounted and getting the electricity generated. Now most of the turbine I can say like almost if it is like 1 megawatt or more than 1 megawatt turbine, it's like standard tower. So we have the standard tower which is like cylindrical shape, not a lattice tower. So the over the tower we have nacelle. The nacelle it's where we have the required components placed, and just in front of the nacelle we have the hub. Over the hub we have a spinner. I used as a cover for the hub, and all the three blades mounted over the hub. So the the capacity of wind generation is mainly based on the sweep area. So the blade length. So normally we calculate from the diameter of the sweep area. So what we have at the stare in the screen, like wind energy math calculation, you can see the sweep area, the circular one. So like Vestas already like acquired Mitsubishi MWOW, and now they are generating almost 9.5 megawatt turbine right now they have, which is the offshore turbine. So we have onshore as well as offshore turbines, and this is how each and every turbine we classify based on the megawatt what it generates, and the megawatt is mainly based on the uh, diameter of the swept area. So what we have the sweep area of the blade, and from the hub as the due to the wind speed, which is at least minimum we need to have for more than 1 megawatt we need to have the wind speed at least 4 to 5 meter per second. And with that wind speed, as the blade rotates, the hub also rotates. So with that there is a shaft getting connected to the gearbox inside the nacelle, and it gets the kinetic energy generated, like wind power to the kinetic energy. And with that shaft rotation, it will have the high speed side in the generator, sorry, in the gearbox. Initially the shaft gets into the low speed of the gearbox. From the gearbox it goes to the high speed of the gearbox, then it gets connected to the generator in the nacelle, and the generator will have it generates the low voltage power. And we have the transformer, HV transformer, which steps up the low voltage to the high voltage. And we cannot have steady wind flow. Also we cannot have steady the power supply or the voltage. So we need to have the steady supply to the grid. So we used to have the conversion area where AC to DC, then DC to AC again, to have that uh, like fluctuations or whatever the grid recovers. So to match the grid power supply, so we have this power generation area, uh, PWM, we say power, we say conversion module, I can say PCM. So PCM is nothing but like power conversion module, and then it goes to the bottom of the tower, then it goes to the grid. So that's how the components of the wind turbine generates the electricity, and it sends the electricity to the grid. And this is the basic of the of any wind turbine. Yeah. Can we have next slide? Yeah. So what additional we can have an other information about the wind turbine, both onshore and offshore. We need to have some signaling system for the aerial objects that arrive near any wind farm, so which has more than one turbine, so it has many turbines in that wind farm. So both offshore and onshore needs the signaling system. So we have NAA system, navigation aid interface system. So this signal will have it has the obstruction light over the top of the turbine, and it gives the signal to the aerial objects like any flight or whatever the flying objects over there it reaches. So it will have the signals from the turbine that there are wind farms are there. So with that, it can have the right path to its destination. Whereas in offshore, in the sea, which are located on the sea, so those must have the same signaling system at the bottom of the tower, because of the ships and other navigating system which arrives near the wind turbine. So it will have the same signaling system at the bottom of the tower as well. Addition to this, we can't reach by any roadways or even by ship also to reach the turbine in the offshore. So we need to use helicopters for the servicemen to land over the heliized area over the nacelle. So we have heliized lamps that are mounted over the nacelle. So it will ensure whether the servicemen from the helicopter can get down over the top of the turbine or not. So there until it glows into green, so he is not allowed to get over the nacelle for any service related area. So it gives a signal that heliized lamp will be there. And to identify which turbine, so each and every turbine on the offshore will have uh, ID marks, I can say, numbers over the top of the nacelle. So to identify that, they have another light called ID light, so that will focus over the nacelle area, and those nacelle area will have the science ID numbers. So based on that, the service person from the helicopter will identify that particular turbine when he comes over the helicopter and lands over it. So these are all the NAA system that we have in the wind turbine to identify which wind turbine or the route of any navigating system, so should identify there as a wind farm. So these are all the navigation aid system that we have in the wind turbines. Yeah. Next, moving on to the next one. Yeah. And for lightning protection, obviously we have SPDs, surge protection devices. So it starts from the tip of the um, blade, and even every corners of the nacelle, so which you can see the right side. So and directly it will come to the bottom of the tower, and all the earth cables will be connected to the earthing area. And when they lay foundation for the tower, so they have the required earthing system at the bottom of the tower. So that will transmit whatever the lightning issues that comes instantly, so that will get transmitted to the bottom of the ground. So that is what they use all these SPD and shield cable. So this such protection devices, it's not will not be there only on the blades, even on the turbines. There will be cabinets. So each and every cabinets of the uh, nacelle area, so we'll have the SPDs inside it, and it transmits all the surge protection, just a surge currents due to the lightning condition will get transmitted to the ground. So, and you can see what is the current peak current value, and what is the total charge that get transmitted. So this is the system that is mainly used for lightning protection. And I think that's it from the wind turbine part area. Yep.
Okay. Thank you, Satish, for helping us understand about the different lighting systems and other which are used in the construction of the wind turbines, and there's certain guidelines related and linked to them. Uh, it's very nice of you to shed light on those aspects. Moving on to our next speaker, which is Rafiq Hussain. He's currently working as the technical director of Cognite, for digitalizing of renewable power plants in the EMEA region. In his earlier instincts at Statkraft, he played pivotal role in the implementation of 2,000 megawatt of wind projects globally. Welcome to you, sir.
Hi, thanks for the introduction. And Satish, it was really nice insight regarding the navigational lights. It was a nice insight for the green.
Welcome.
Yeah, thanks a lot. So I'll just be trying to give you some key insights, but I will also try to give you some insights regarding why these numbers are coming, what is growing or driving these numbers today. So thanks a lot for introducing me, Himanshu. So yeah, let's go to the first slide, I guess. Yeah, so of course, the global capacity is increasing. I'm not gonna pronounce and mention each of these numbers. I think Anchal did a fantastic job. Thanks a lot for doing a lot of the heavy works. But there is a global drive on moving towards the renewable energy. So this is both a political and environmental aspect. So all the regions are trying to push very heavily, and we could see that China and US are mostly dominating the market. But of course, in terms of percentage of power consumed, we also see that Europe is doing a great job in terms of research and development as well. So there are different aspects. So one is just production, where how you're producing all the powers generated in terms of numbers, but also we see the research and development base where the new technologies for operation and maintenance are kind of better handled in Europe as well. And of course, we see that the year-to-year growth is 10% because of the new CO2 and energy policies that are coming in. And we could only expect that it's going to increase another 40 to 50% over the next 7 to 10 years. And of course, the biggest drive is on the onshore, towards the offshore side, because onshore is a bit tricky due to the acceptance politically and environmental acceptance. We see that the offshore sites are being pushed a lot more right now in the industry. And I will just discuss this further as we go forward. Himanshu, you can move to the next slide.
Yeah.
Yeah. So of course, it's really interesting. We see right now all the new turbine installation, almost 60% of them are greater than 4 megawatts, right? So of course, Siemens, Gamesa, Vestas, GE, so they are really leading the way by implementing the newest R&D studies and just implementing it as fast as they could to increase the efficiency. And we immediately see that the efficiency, or we call it also capacity factor, but for the audience, I will say the efficiency has increased from 35 to 45%. And of course, what it means is that when you say a turbine is producing 5 megawatts, we mean 5 megawatts rated. It's not producing 5 megawatts all the time. So when we see the efficiency of a turbine is, for example, 35%, it means that on average, it's producing 35% of that 5 megawatts. So it's that's how we kind of measure it, right? But of course, the efficiency improvement is being massive because also turbines are being produced further for offshore industry, and it makes it easier because the wind is more stable. And of course, there are floating wind farms. They're coming into operation as well. One of the main reasons that this is being pushed is because of the installation cost. So the installation cost reduces a lot because you don't have to do the piling on offshore installation, because that's a massive cost. You will see that most of the new offshore wind farms are kind of being pushed further away from the on-site substations, or we say the grid connectivity, right? So what it does is that the piling cost really increases. So that's why we see a huge push to the floating wind farm. And what this is causing is the LCOE is also reducing. And what it's doing is it's making more further investments or more asset owners to be interested on this, because they see that this is actually a profitable business. There is one interesting though. This is the reason I also mentioned the energy storage integration, why this is important, because the more you install wind turbines or wind farm into a sector, you will have issues of grid stabilization. So that's why we see that further integration of wind farms into a country or into the utility side of any country. They want to also involve energy storage so that it's also able to kind of both stabilize the grid during, let's say, unplanned maintenance or when the wind speed is maybe not predictable, and also maybe to store additional power because of market operation, because there is also a new thing which is very important, which is power markets, right? So now it's not only electricity generation anymore. There's a huge game of power markets, and that itself could be another topic of discussion one day. Would love to discuss about. Yeah, Himanshu, you could just move to the next slide. Yeah, so it's very interesting that we see that the global capacity, the biggest global capacity is actually in the Asian region, which is very interesting. So China is targeting 250 gigawatts by 2025, and that is insane. And very interesting to see. So they're just producing and producing. Although most of the top Chinese wind producers we really don't know the name of, but please just have a look. I would recommend the audience like what's happening right now. And of course, North America is seeing the interest in this. And the funny part is a lot of these investments are actually coming from oil companies as well, because they're trying to heavily invest and enter the renewable market, because they see that this is what's bringing the money and also where people are interested in investing. So US is targeting a 30 gigawatt offshore by 2030. So 10 years ago or 5 years ago, the interest for US in the wind industry was not as massive, but we see that the North American industry is just exploded right now. And African growth market, so it increased by another 100% compared to last year. And Latin America, so I myself was involved in one of the largest onshore wind farm in South America and Chile. So they're heavily investing in wind farms. Of course, one of the key problems there is they don't have the competence or the knowledge of both building, commissioning, and maintaining. So that's where we're collaborating with them from Europe. So they're using the technical expertise and the knowledge from our side to at least commission these wind farms and also how to maintain them, because this is something we're also going to talk about, like regarding the challenges. Yeah, Himanshu, you could go to the next slide. So of course, the nicest part is the investment. So private sector itself is contributing to 60% of these $180 billion in 2023 alone, because they see the massive amount of return or potential return that they have been seeing for the last 5 or 10 years. And most importantly, it's creating jobs. So I think it's expected that 100 million new jobs will be created due to the entire wind sector by 2030. And of course, the supply chain growth, you could see that it's almost 15% annually for wind power, and blade manufacturing growing at 20%, because the demand is just growing massively. And of course, the top 5 are controlling 60% of the market share, the big names, as you could see. And there are a few others, but please, I would recommend the audience just to have a quick Google on that as well, because you will understand how the market is being driven in different part of the world. Yeah, Mancho. Yeah, so of course, what is driving all these numbers? It's very important because first is CO2 emission reduction. So this is both for individual country-wise. They want to be greener. They want to contribute towards the sustainability and the green part of the world. So they see that the increased CO2 emission reduction. And of course, it's very important because as you're also building all these wind farms, you have to consider the wildlife protection. So we take criticism very seriously. So whenever you're going into the wind industry, you have to do a very precise environmental report, which kind of actually makes the audience or the people learn about the local wildlife environment, and you kind of understand where you could build or not build the wind farm. So this is something much better or improved over the last decade, I would say. And also the land use. Right now, of course, we're using 0.05, but the interesting part is people are also combining agricultural sector with the wind farm because it kind of makes it easier so that you're keeping both sides happy. Of course, in many parts of the world, because it's increasing so rapidly, they are reduced because of delays and some public acceptance issues we see in some parts of the world, especially in Northern Europe in some parts and also in some parts of the US. And that is natural, which is absolutely fine. uh, because you want the community to be critical. What it's going to bring, what is it going to produce, how much value it will give to the local people, what will it contribute. So that's where you kind of have community engagement and strategic planning with the local community, and that's very important. So this is something very new as well. Over the last 5 or 10 years, I would say, has improved a lot, which was not existing as well over the last 10 years, I would say. So it has increased a lot. Yeah, Himanshu, just and this is very interesting. So I would like to spend some time, and I would also ask the audience to ask a few questions on this. So the current O&M, or operation and maintenance challenges, for both the OEMs and the asset owner for the wind turbines. It's very interesting. So because of the volume of all these wind turbines being produced at such a fast pace, the number of unplanned maintenance, where you get a lot of alarms which are not related or planned, are increasing in very tricky terrain. So it could be both offshore in a very tricky environment and onshore, very far away from local place, right? And what happens is your operation and maintenance cost increases as well, which you maybe not have taken into consideration. And of course, the data that is coming in, and this is a thing that is kind of coming back and forth from the turbine suppliers and the asset owners, who owns the data. So this is something which is very new over the last 5-10 years. The asset owners, who also want to do their own operation and maintenance, they want to have ownership of the data coming in from their turbine. And of course, this is a policy which has to be made. It is not there currently made in Europe, at least. And I think once it's made in Europe, or it will be implemented on the rest of the world. So this is something that we're working towards on, I know, but this is a huge issue because the data would allow easier operation and maintenance from both sides. But this is something I would expect both the turbine suppliers and the asset owners to work together. Um, and of course, regions with higher mix of wind power, they have difficulties on grid balancing. That's why we're kind of talking about battery storage or energy storage management, because it kind of allows you to balance the grid in a better way. And of course, there is cybersecurity. So over the last few years, we have seen some big names get actually attacked by many threats. They were hacked, their systems were hacked, and it actually also affected the asset owners. And there were big names. I would also recommend the audience to check what actually happened. And it kind of shows the vulnerability because of the current political environment that we are in. We see this increasing very much. And it not only affects the turbine suppliers, it affects the asset owners, but also the entire country's grid, because it's directly connected to the utility grid, right? And the other part I would say is the technical operation and maintenance documentation and governing documents. They're not standardized yet. So we see that in different regions, there are different governing documents that are kind of focusing on each specific country, which is okay, but it still should be standardized in some way so that it makes it easier for the operation and maintenance, for different maintenance personnel to have the same standard and views. Otherwise, it's just going to create further increase in cost and time for performing both planned and unplanned maintenance. Yeah, I think if you go to the Next one. Yeah. So of course, there are some challenges. One of the biggest challenges I would say right now in our current situation is actually maintenance, operation maintenance for the wind farm, because we see that a lot of turbine suppliers actually are having difficulty because of the large number of turbines, uh, some unplanned maintenance cost, and actually made them have heavy or huge losses. I will not mention any names, but again, I will ask my speakers to check some of the biggest name which are actually having difficulty, and they actually didn't go bankrupt, but they kind of joined their parent company because they had heavy losses which they did not expect. But of course, nevertheless, the wind industry will grow rapidly, 1,000 gigawatts by 2030, and offshore growth will occur 50% annual, 15% annually, no matter what. And there will be R&D investments. I'm expecting 10 billion years, $10 billion over the next 5 years. And the new focus would be how to use AI and digitalization to kind of make it easier. Because right now, the amount of data that's coming in from all these turbines is tremendous. And you have to, I think my fellow speaker Satish would also agree that for performing better R&D on both the asset owner side and also the turbine supplier side, you need to have data clarity and openness to perform this digitalization. And of course, the hybrid systems and energy storage and drone monitoring, all this would contribute to make all this easier. From my side, so I was working mostly on the tender part, tendering documentation, and choosing who would be the turbine suppliers, and working during the O&M phase. We saw that collaboration only helped a lot. So we only asked for openness, like could you make sure that we have data openness, innovation openness, and what it allowed was that you have a better wind farm, very structured and synchronized both within the turbine suppliers and the asset owners when they work together. And of course, I assume the challenges are different in different part of the world because of the policies that are created, and also the documentation and the tender documents that are created right in the beginning. So I would also recommend that we work together towards a sustainability goal, because the goal is to massively reduce or move towards complete renewable by 2050 for most part of the world. Yeah, thanks a lot to Manchu. I think the next slide is yeah. So feel free to ask questions later, or add me up on LinkedIn, and also just add your questions on the comments. Yeah, thanks a lot, Himanshu.
Yeah. So we do have received a number of questions from the attendees. So let me quickly flash one for you. So this is a question in general for both of the speakers today. That so while setting up a wind turbine, what are the factors that impact the amount of wind energy that can be generated from the wind and turbine?
I think I would leave this question to my fellow speaker.
Yep. So it's there is a team called Wind Capturing System. So they just see the place, the altitude, and what is the wind flow over there. So they have various sensors and other stuff to capture the wind capacity. So with that, they will decide whether they can have the turbines installed in that particular area to generate a certain amount of or a certain megawatt of electricity or not. So that's the team. Like wind capturing system is the team. So they have the factors of wind flow and altitude, and also it should not be on closer to a defense area. So we have a lot of components like IntelliLight system, so which has the radar in it. So that should not impact the in defense area system. So it should not be closer to defense area, and also it should not have more sound. If it is residential, some residential areas there. So residential in the area, in the sense like they have some farm areas nearby, and that should not create any sound or this thing. So all these factors considered to first have the wind turbine installed, and amount of energy is mainly based on the wind speed and also the altitude of the area.
So just to
Oh,
add, Satish,
Yep.
like you just said, the wind turbine and the altitude speed. So what is the reason that Middle East is very behind from all other regions? Maybe they are just focusing on oil. Now they are diversifying the economy. They are focusing on renewable energy. But still, if we see the stats, if we see the figures from 2011 to 2022, they are still far behind, even from Africa, other regions. What's the kind of reason behind that? What can be the
Uh,
reason?
yeah. Mainly, just like that, we cannot have a wind turbine installed over there. So they should get right, when they say clearance from the government, and also it has to meet the standard. So when we have particular turbine installed in particular area, so even there are some kind of cleaning agents which comes automatically, so that should not affect the standards over there. So based on the clearance from the government and some certain agencies, so with those permissions only we can have the wind turbine installed. So I'm not sure what about the Gulf areas, why they're not having. So I assume like they may have the issue of getting the permission, the clearance from the various departments.
Yeah, I could also add here, Anshul, one of the key reasons is right now, in general, the price of oil is very cheap. And
Right.
of
yeah.
course, the production for energy for them right now, as we see the LCOE, as we see, it is very cheap for them. But we see that they're planning to do massive amount of integration for solar, actually,
Mhm.
in the Middle East. That is going to be mm, bigger key player than wind. That is at least my consideration. So we see that a lot of solar farms are being planned, and the ones that are being planned, they're humongous. They're actually, up to 2, 3, 400 megawatts. That is just insanely humongous, right? So they're being planned. Um, by a lot of these Gulf companies. I can't name because I think these are just not out in the media yet. But it's gonna come, and when you will see it, you will see the numbers just rise. How do you call it? Just rise very exponentially in the Middle East. And that is something we're expecting. But as of today, right now, the cost LCOE coming the power generated from the oil sector, it's still very low. So that's what hasn't really driven them really yet. And of course, they are not part. Some of the countries are not part of the CO2 emission or like the goal, and it's not really driving them or punishing for CO2 production in a way. So there's no motivation, right? So all these factors are motivating other countries, but for them, they're like, why would we need it? It has to bring value, and not only for sustainability, but for the local citizens or the local population. So when that happens, and that is happening right now, they see the growth in population. When that happens, it's going to come very fast.
Okay.
I agree with Rafid on that part that when it is coming to Gulf countries, they are trying to diversify from oil, but at the same time, instead of turning towards the wind energy, they are trying to turn more towards the solar energy because I believe that they are rich sources in that matter, and that is a way ahead for moving forward.
Sure.
Moving on, I do have received another question. This is specific to you, Satish. You mentioned about the navigation aid interface. So basically, it is a two-part question. Are there specific companies that operate into navigation aid interface systems into manufacturing of these kinds of systems? And second thing, like you mentioned about certain guidelines or authorities which mandate that there's a particular kind of lighting or there's a particular intensity of lighting which needs to be used at different altitude for visibility or for increasing the safety. Can you tell us more about such guidelines specific to India?
To the answering to the first question, it is like there are Vestas just get the supplier directly, or whatever the NA system, so readily available from the market, so from the various suppliers, and directly they install on the site. anyway, we just the sourcing part for the customer, so we just give from our side, whereas the supplier will directly come over there. So there are a lot of suppliers who are providing NA systems for wind turbines. And second part for I really don't know who about the Indian guidelines, so I have just mentioned in the presentation about other areas. So maybe I'll just get back later. I really don't have any guidelines about what all, because I just manage mostly on in NAOD and European division, so I didn't get a chance to get for the Indian guideline system. Yeah.
Okay. Uh, then we have another question. Okay, can you tell us about the certain key technological advancements that are happening in the wind power energy sector in general?
Yeah, the main thing is like as I already told, like IntelliLight system. So IntelliLight system is a thing like we can have only one IntelliLight system for one turbine for almost the wind farm having some 30-40 turbines. So no need to have right now we need to have ADLS system like aircraft reduction system. So that should be there in each and every turbine. So instead of that, we can have only one IntelliLight system, so which will have the radar on one lattice tower or on any one of the turbines in the wind farm. So that is one thing which is newly added into Vestas turbine. And apart from that, we have going to say kind of like Rafid said, like a SCADA system. So that is right now when compared to earlier times. Now the SCADA system it's much more useful to have everything like automated. I can say like we can have the monitoring system, advanced monitoring system of the turbine about the wind log and what is the shutdown time, what is the energy production. So everything in a single go. So which was taking like system 6000 was the thing earlier were used. So we have each and every areas different kind of controllers were there. Now it is system 8000. So from 6000 to 8000 it got moved, which is like we have various DCN distribution control nodes for one system only for nacelle. One DCN will be there, hub only one DCN will be there, and blade it will be one. And for the bottom of the tower ground controller there will be one DCN, and they have TTE, time triggered Ethernet. So it will get all the details from all the DCN. So instead of having various controllers, now only one DCN for each and every area, and it gets all the details like from all the turbines, and it is very easy for having the monitoring system done. Yeah.
So
Thank you
just
so
to
This is
much.
add, like technologies like digital twin, IoT, artificial intelligence, like just to add Himanshu, so these technologies are also used in simulation and monitoring of wind turbines currently. They are just developing. The companies are exploring these technologies to simulate and monitor the performance of wind turbines along with wind nacelle, so that they can utilize more capacity from wind turbines.
Yeah,
Okay,
yeah.
I would like to come back to that. So, Achal, like you just mentioned about the digital twin. Rafid, in your presentation, also you mentioned about the key technologies and the utilization of the technologies to boost the overall process. You also mentioned about the cybersecurity in general. Can you enlighten us about the role of the cybersecurity and digital twin technologies in improving the simulation and performance of wind turbines in general?
Yeah, so the term digital twin, everyone thinks that it's just a 3D model of an exact replica of a turbine or plant or anything in general. So before I just do a deep dive, I'll just take 20 seconds to explain what is a digital twin. So a digital twin is actually a combination of a data twin. So all the data, for example, what Satish was saying, coming from the nacelle, from the tower, from the SCADA system, from the vibration monitoring of the turbine, that's a data twin. And then there's the asset twin. Asset twin is, different asset and the sub asset of the turbine. So wind turbine in general, and then it has blades, three blades, the nacelle, the generator, the tower, and then how you're connecting all that data to each part of the turbine. So you're kind of aligning them. And then you have the visual twin, which is the 3D part. So when you combine all these three parts together, you create a digital twin of a turbine, which means that you have a complete holistic overview for the turbine. What it creates is you are able to perform a lot of certain things, because as of today, at least the SCADA systems which we were using previously, we were only able to see, let's say, some of the SCADA data, so which is the electrical characteristics or such, and the grid characteristic, but we were not able to see the vibration data in the same place, or we were not able to see the load characteristic, which is the torque or the tension of the tower. Very different, completely three different aspects. But right now, because of this digital twin, this is what I'm working towards, right? We're able to combine all these three under the same environment. So we're able to create a digital twin for a wind farm. So we're not only able to see, for example, how much lightning, what was the power of the lightning, or how much effect it had on that lightning, but we're also able to see the torque or the shaft or the bending moment, or what impact it had, the mechanical structure, mechanical failure, and also the SCADA system, how it was impacted during that lightning. So we're all able to see that under the same platform instead of using different application. So what it enables is the maintenance personnel who's going out on the field, they will have a complete overview for the turbine because of this digital twin. And of course, when we say simulation, we are talking about predictive maintenance. So when you do predictive maintenance of the turbine, let's say you are seeing that, for example, a blade or a tower, especially a blade, is having some micro cracks or some cracks or failures, right? And you will see that the vibration characteristic is a bit different. What you will do is you will see that before it reaches that threshold, by using predictive maintenance or predictive analytics, you could perform or do that simulation. We call it simulation, or many other name. You could say the maintenance personnel beforehand to stop that failure, which will increase the downtime of the turbine. So that's where simulation and digital twin kind of come in to enhance the monitoring, right? And then the cybersecurity part, this is a bit different than what we're kind of talking about, but it is vitally important. So we see right now in some regions of the world, a lot of companies, especially in the European sector, a lot of the wind turbine companies are being affected or attacked vigorously, almost on a daily basis. So just a statistics, I would say that just 3 years ago, we used to get 1,500 spam emails, right? Just with fake numbers, fake emails, and of course it was blocked by our system. But it's never enough. So you have to constantly upgrade your OS systems at a constant basis, not only at your headquarters, but also at the plant site where the personnel's field workers are using their own laptop. So it's very important that they're constantly updating their OS Windows. Mostly it's Windows right now, so they have to update it accordingly due to security. So one of the measurements they should do is follow the cybersecurity measurements that's specified for each specific country, but also take individual responsibility, because that is the biggest lacking that we see when we are seeing cybersecurity. Because we see that all these cyber attacks are actually occurring from one person's mistake when clicking a link, and then the attacker gets entrance into the entire network, right? And it's very difficult to find our pinpoint. So it's very important that we take individual measurement as well, besides taking corporate measurement for cybersecurity. So that's why we used to have a lot of cybersecurity seminars or lectures, which are not only recommended, but were mandatory. And that was normal, because in a company you will have people from several age, right? You will have the youngsters who are maybe a bit more adapt to the current computer network, but people who are 60 or 70, they're not maybe updating their OS regularly, and they're still in the network. So it's important that it's mandatory for everyone. Yeah, Himanshu, just to clarify.
So, Rafid, just to add on that, like you have mentioned about digital twin, then advanced monitoring. So, do you guys also use like metaverse and Web 3.0? These are the emerging technologies right now in the energy industry. So, how they are helping in wind power currently?
So we don't use metaverse yet, but we're using AI
Okay.
extensively. So for example, our company, we're a partner with Microsoft, so we have actually incorporated AI into our software Cognite. What we're doing is you're able to have a conversation with your asset. So once that digital twin is in the system, right, with all the data which is connected to the asset, you're able to have conversation with your asset. You could ask, are you reaching the threshold today? What should I do? What should be the maintenance? What should be the maintenance procedure for next day? What was done previously? You could have conversation with your asset. That's where we're reaching. So we have already done that in the oil and gas sector. Just so you know,
Okay.
this is not something mythical. So I would also ask my audience to have a look on what we have done for the oil and gas sector. What's happening? It's way advanced because they've invested so much. So the investment in the renewable sector for AI and digital twin is just starting because of all these problems and the amount of turbines coming in. They see the importance that we have to do faster maintenance. We cannot just exponentially increase the number of people on the field as we increase the number of turbines. That is just going to blow up the cost. So that's where AI comes in to help perform predictive maintenance, have conversation with your assets, people who are not analysts but could be analysts just by asking the right questions to the turbine. And that is where AI is providing a lot of value, reducing OPEX, or we call the operational cost and expenditure, and also the downtime. And we see a direct impact on that as well. But metaverse is not there yet. Virtual reality, there are some things that are coming, but just from a utility scale. At the end of the day, you want something to be implemented globally. I still see that it's not yet popular between, for example, the persons working on site. That it's still there to be implemented. But AI, where something is handheld device, they're used to it. So we just try to improve the current technology that's already there.
Okay.
Yeah.
Yeah, like you just mentioned, it's really exciting that now you can actually get to interact with the components again AI wise, so that you can know and monitor the health, whether the particular component in the turbine is going to reach the required threshold or not. I also think that Web 3.0, or for that matter AR VR, are not that much feasible, or not, or will not be utilized on a commercial scale as of now. But I believe that those parts could be used for the training, but not on the on-site or other places. Uh, do you think that with the emergence of the advanced monitoring and sensor technologies, we can now predict or prevent potential mechanical failures in wind turbines?
Yeah, absolutely. This is already happening. Uh, uh, just, I think, so I've worked actually with Vestas before. So previously, we implemented the condition monitoring software. So we call it CMS condition monitoring software. What it really does is it allows you to get the vibration characteristics for the blades, for the nacelle, for the gearbox, and you're able to perform predictive maintenance, right? So these sensors are not common in all turbines, and that's the part where it's very different in the European market and the market in China. So in the Chinese market, there are a lot of failures because they don't have these sensors. So we saw that in a wind farm in Brazil that was installed by some of the Chinese companies, they did not install these sensors. And what happened was the maintenance cost was just uprising because they could not predict failures. So when you have this condition monitoring sensors implemented in different parts of these turbines, it really allows you to enhance the predictive maintenance feature of the turbine. And that's where I think the market is going towards. Otherwise, we will see that the operational cost would increase just rapidly. And of course, the data being shared, that's where I also say the data being shared both by the turbine suppliers and to the asset owners, that's very important, because as of today, it's only the turbine suppliers who have the complete knowledge on what's happening with this vibration data, not the asset owners. Most of them, they have no idea. They just want to collect the data. So they're still on a learning curve. And it's more like a business side of the topic, why the data is not giving. So I will not go on that side. It's a bit different, becomes a bit political. So yeah, answer to your question is yes, absolutely.
Satish, would you like to add something to that from your use case?
Yeah, in the advanced monitoring system, so right now, in Vestas, we have the conditioning monitoring software. So it is like I personally saw some of the cases, like because of the conditioning monitoring system, they were identified like some parts are really going to have the failure nearby. So the coupler between the gearbox and the uh, generator, so it is not exactly the metallic one, so it is like a fiber optic, fiber plastic. So it was having little crack, so that was identified, and also there is a ring and the blade LCTU, lightning current transfer unit. So that was having a failure, which was not failed, about to get failed. So those are the things got identified, and before the failure, so this monitoring system identified those failures well before it should happen. So, but it got prevented, and because of this advanced monitoring system, like we can prevent many failures and also have the uh, even maintenance, which whenever needed, it can be done like using this advanced monitoring system.
And one addition to Satish and also Himanshu, your question. So over the last few years, we saw the importance of these condition monitoring system. This is going to be a huge market over the next few years for all turbine companies, definitely. We saw or we see the need for this absolutely. So I would also say audience who are maybe in the university to check, who are in the mechanical engineering sector to check. Some idea on, okay, maybe I would want to understand a bit more on vibration monitoring, because that's a huge market right now that's upcoming. Yeah.
Sure. While setting up a wind energy plant, what are the potential environmental effects? What are the ethical considerations that people take for setting an offshore wind energy plant? And what can we do to minimize or control it?
Yeah, I think I can go, but also want Satish to give your insight on this. So there are two aspects here, right? And I'm talking about the utility scale offshore wind farm, which will be connected to the national grid. So both the asset owner has a responsibility to provide an environmental report, and the turbine manufacturer, they also have to provide an environmental assessment report. So first, we have to consider, of course, the seabed condition. We have to see what kind of life forms are there, what kind of environmental or like what kind of animals or fishes would be impacted by that. That's very important. And if there are any critical or very rare animals which are very protected wildlife, if they're impacted, you actually have to shift the entire plan to a different site. uh, and then there is the cable lines. If there are any other cables going through there, if there are any radio impact, you have to think about if there are any radio lines or radio network going through there. You have to think about the bird life. You have to think about military protected areas. You have to think about the shipping routes. You have to think about landmines that were there during the World War II. And there are many other, quite a few. So I would, if it's possible, I would recommend a website which I would share later, maybe with you guys, to have a look. What are the potential places to build a wind farm, because once you actually take into consideration all these aspects, you will see that in the end you're left with a very small circle. It's not much left in the end when you're thinking of for an offshore wind farm. Satish, if you had something to add as well.
I think you have covered most part of the potential things, like it's mainly like cable route between various turbines in the offshore. It is really a biggest task, and that should really not uh, cause any issues in the seabed as well. So there is a link which shows uh, the global installation of the wind turbine, offshore wind turbines. So if you see that one, so I can provide that link later. So if you see that one, though, some of the cable routes, it's not like routed exactly very close to one turbine to another. So to it should not affect the aquatic life as well as and other the sea areas. So they route the cable route like takes longer way sometimes, just to avoid any issue to the sea areas as well as the aquatic life. And addition to that, like it should not have any interference with the military area, the defense areas. So that causes a major issue. So already, as Rafet said, like there will be a team who consider what are all the factors or that affects uh, the area where they are going to install the turbine. So they check each and everything, including the pollution, sound pollution, and it should not be harmful to the birds in the offshore turbines. So and also aquatic life. So these are all the potentials, mainly the factors they consider when they have the offshore turbines installed. Yeah.
Yeah.
So,
Yeah, last. Oh yeah, sorry. Last thing was also the connection to the grid, the length, how far it is
Yeah.
from the substation. Yeah, that one was very important. Yeah, sorry, Himanshu.
yeah, I was going to ask that how can policymakers support the development in the process of wind power? And can you guys share some of the most effective policy frameworks that you have seen implemented in your countries or regions?
Uh, I think, of course, the global or the CO2 world CO2 meeting that we have every year. So of course the European market, like the global CO2 Commission or emission goal by 2050, 2030. So first it was 2020 back in 2010, then it was 2030, where a lot of the countries already reach their goal of producing or reaching certain percentage of the electricity generated by renewable, and now it's 2050. So the goal or target was much lower, but now it's much higher. So now they want to reach another target on what would be the electricity generated by renewable production. But again, this is not the same in every country as we see today. So some countries really adapt to that very closely, to those policies, and it depends on each country's framework or goal on for sustainability. For example, in Norway, it really helps that 98% of the power is generated by hydropower, almost all of it. So I think Norway is a bit special on that, but rest of the countries are really trying to follow through, especially in Northern Europe. In Southern Europe, in Italy and Spain, of course, Spain is a fantastic example after Germany in Southern Europe, but rest of the countries like Italy or Portugal, they're still following through towards those policy. Asia, again, I'm coming, as I said, from Bangladesh. We're still far away from that goal because of a lot of issues, mostly political, I would say, rather than technical or environmental. But I really hope that we're going to reach there. Yeah.
I think like feed-in tariffs, FITs the governments are providing, the subsidies they are giving, financial incentives, and in India like hybrid policies, their solar wind policy. So the government is implementing, of course, the Paris Agreement, the carbon emissions targets, So these are the policies which are supporting the wind power all over the globe, actually, all across the globe. These are the major policies which are driving the wind power along with the renewables. Basically, the
Yes.
FITs, they are providing feed-in tariffs, and the financial incentives obviously is a way more to like attract the policymakers to go into renewables. The companies go renewables because of the financial incentive, the subsidies. So basically, these are the policies.
Yes, yeah, the Paris Agreement. That's what was not coming into my head. I was, yeah,
Yeah.
it was which was the Paris Agreement, and of course,
Go on.
that's why I was actually going to mention Middle East when when you were asking why Middle East
Yeah.
is not there. They are not involved in Paris Agreement, right? So that also kind of lets them be free on what they want to do. That's why they're not focusing that much on renewable. And as I said, the Paris Agreement really affects the Northern European countries because their electricity consumption per capita is higher, and also the production and everything is higher. So that's why they really have to follow through. Otherwise, they not only get positive tariffs but also get negative. So they also get deducted. So they get CO2 fines, as you say, like per ton on additional CO2 provided. So a lot of the companies now, when you try to work with them, they want to see your sustainability report, as we have to provide our sustainability report per employee, for example, to show how we are sustainable. So it also kind of drives the other company or other country wise to go forward. Yeah.
Totally agreed on that. Like Middle East, like we can see that in Africa, South Africa is doing very good in terms of solar, like solar inverters, solar batteries, solar systems. But African countries are doing way good than Middle Eastern countries in terms of renewable installation. What I feel.
Yeah, absolutely, absolutely. They have a lot of land, open land. They have a lot of environment for both, which are what you call suitable for the wind. So it allows them to grow really fast, and I'm not expecting any slow that to be slow over the next decade or so. I had a question to Satish, if I may ask. So this is more like maybe if you want to answer. So what is the next step on the turbine size? Like I know it's already 164 meters, right? So how big is it gonna get?
It's like now it's like 236. It's like 164. Now it's like 236. It's 10 megawatt. So
Yeah.
that's the next turbine that is on. It's already the first prototype been installed. It's already they are started generating the electricity. So the power generation is started for that V236. It's like 236. Earlier it was V164. Now it's V236 and producing 10 megawatt.
Oh, that is
That's a
huge.
monster. It looks
That
like
is
monster actually.
monster. 236.
Yeah.
I can't even picture that one.
Yeah, and
And
earlier it was only the nacelle. The nacelle was there. Now it has the side chips. So we are I worked on the all NAI and power backup system, and also the DCN areas. So like distribution control nodes. So it's like they added earlier the V164 was not having any side chips. So right now both the left and right sides of the uh, nacelle has the side chips, so it looks monster when compared to V164.
yeah, I will
Okay,
Google that one.
so that's all from my side, and that's all the questions we had. Thank you to all the speakers for joining us today. It was really informative session, and I believe most of our attendees got insights into the wind power landscape in general across different countries and got better perspective of the things, particularly the new fields that emerging areas they need to focus on, like you mentioned about the vibration monitoring and other aspects as well. So until then, have a nice day, guys.
Yeah.
Thank you all.
Thank you both. Thanks a
Thank
lot.
you.
Bye.
Okay. Bye.
Bye bye.